And the craziest part is, those chatbots you're using every day, they're not actually knowing anything in the way we think. It's all about probability and context. We're talking hundreds of billions of parameters just to simulate understanding.
Hundreds of billions? That's staggering. So all that data is just sitting there, waiting to be activated?
Exactly. And that's where the RAG versus fine-tuning debate really heats up. Because how do you actually get those parameters to do something useful for your specific problem?
Right, because every company isn't just trying to generally answer questions about the world. We have our own internal data, our own customers, our own specific needs.
Precisely. And choosing the wrong approach can be a disaster. Imagine Netflix trying to recommend shows based on a model fine-tuned on, I don't know, Reddit comments. It would be chaos.
Oh God, the recommendations would be something else. So what's the real cost of getting this wrong, beyond just bad recommendations?
Think about it. Wasted engineering time, hallucinating chatbots giving incorrect information to customers, regulatory compliance nightmares. The stakes are incredibly high. We're talking about potentially misleading users, losing their trust, and even facing legal repercussions. Imagine an Uber chatbot giving drivers incorrect routing information based on outdated data. People could get seriously hurt.
Okay, so it's not just a theoretical problem. This is impacting real businesses and real people. Let's start with RAG. Explain it to me like I'm a smart engineer who hasn't spent the last year neck-deep in LLMs.
Okay, picture this. RAG is like having a super smart research assistant with access to a giant, constantly updated library. The assistant doesn't memorize the entire library, that'd be impossible. Instead, when you ask a question, it quickly searches the library for the most relevant passages and then uses those passages to formulate an answer.
So the library is my company's knowledge base, right? Documentation, internal wikis, customer support tickets.
Exactly. And the key is that the LLM itself isn't directly trained on that data. It's just using it as context for generating responses. Think of it as reading comprehension on steroids.
Okay, that makes sense. So what are the strengths? It sounds like it's good for keeping up to date with new information.
That's a huge one. Real-time updates are RAG's bread and butter. Imagine Cloudflare needing to update their security protocols in response to a new threat. With RAG, they can quickly ingest the latest threat intelligence and immediately start providing updated guidance to their customers. No lengthy retraining process required. The other big one is explainability. You can trace back exactly where the information came from.
Because you have the source documents right there. That's huge for debugging and for trust. But what about the weaknesses? It can't be all sunshine and roses.
The biggest weakness is that the quality of the answer is entirely dependent on the quality of the library and the effectiveness of the retrieval mechanism. Garbage in, garbage out, as they say. If your knowledge base is poorly organized or your search algorithm is weak, RAG will struggle. Plus, it can sometimes struggle with complex reasoning that requires synthesizing information from multiple sources.
So it's good for answering factual questions based on existing documents, but not so good for, say, generating new strategic insights.
Precisely. Now, let's flip to fine-tuning. Think of fine-tuning like training a chef to specialize in a particular cuisine. You start with a general-purpose chef, a pre-trained LLM, and then you give them a ton of examples of, say, Italian dishes. Over time, they learn the nuances of Italian cooking and become experts.
So you're taking a model that already understands language and teaching it to speak in a specific way, or to perform a specific task.
Exactly. You're adjusting the weights of the neural network to optimize it for your specific use case. It's a much more intensive process than RAG.
So what are the advantages then? Why would anyone choose fine-tuning over RAG?
Fine-tuning can lead to much better performance on specific tasks, especially when you need the model to be creative or to generate novel content. Think about OpenAI fine-tuning a model to write code, or Meta fine-tuning a model to generate realistic avatars. Also, a fine-tuned model can be much faster and more efficient than RAG because it doesn't need to retrieve information from an external source every time it generates a response.
Speed and performance, that makes sense. But I'm guessing there are downsides.
Oh, absolutely. The biggest one is the cost and complexity. Fine-tuning requires a lot of data and a lot of compute power. It can also be prone to overfitting, where the model learns the training data too well and performs poorly on new data. And unlike RAG, it's much harder to keep a fine-tuned model up to date with new information. You have to retrain the entire model every time you want to incorporate new data.
So it's like committing to a specific culinary style. If you suddenly need to start making sushi, you have to retrain your chef from scratch.
Exactly. And here's the crazy part. Fine-tuning can actually degrade the model's general knowledge if you're not careful. It can become so specialized that it forgets how to do other things.
Wait, really? So you could make it worse?
Absolutely. It's called catastrophic forgetting. Imagine fine-tuning a model to summarize legal documents. If you don't include enough general knowledge data in the training set, it might start hallucinating facts or misinterpreting legal concepts.
Okay, so we've got RAG, which is great for up-to-date information and explainability, but can struggle with complex reasoning. And we've got fine-tuning, which can be faster and more performant, but is expensive, complex, and can even make the model worse. Is there a middle ground?
There is, and this is where it gets really interesting. It's called fine-tuning for retrieval. The idea is to fine-tune the model not to generate text directly, but to improve its ability to retrieve relevant information for RAG.
So you're fine-tuning the retrieval mechanism itself?
Exactly. You're teaching the model to better understand your data and to identify the most relevant passages for a given query. Think of it like training your research assistant to be a better researcher. This can significantly improve the accuracy and relevance of RAG responses without the risks and costs of fine-tuning the entire model.
That's clever. So you get the benefits of both approaches without the downsides, at least in theory.
In theory, yes, but it's still a relatively new area of research, and it can be tricky to get right. You need to carefully design your training data and your evaluation metrics. Think of it as training your brain to be a better researcher.
Okay, so that's concrete. So it's about thoughtful evaluation, iterative experimentation, and exploring the hybrid approach.
Exactly. Because in the end, the best approach is the one that solves your specific problem, not the one that's getting the most hype on Twitter.
Well said. So the untold truth is RAG and fine-tuning aren't enemies, they're tools. And like any tool, the right one depends entirely on the job.